Good evening, ladies and gentlemen. I hope that all of you are studying for your big test either tomorrow or on Wednesday. You see that you only need to pick 10 of these total, and if you do more, you get extra credit. So that being said, let's take a look at some of these problems. These are going to be very similar to the ones that you have on your CA either tomorrow or Wednesday. Looking at this first one, it's asking you to identify the domain and the range for this function that's above. Your domain are your x values, and your range are your y values that are included in your function. My x value, I'm looking for the value that's the furthest to the left. This minimum x value is -3. The variable for domain is x, and my maximum is the value that's the furthest to the right. That's 2. The open dot means that at -3, my sign is going to be less than. X cannot be -3. At x equals 2, there's a closed dot. That means that the x is less than or equal to 2 because x can be 2 in this solution. We're going to follow along with the same steps for y values. My minimum y value is my lowest y value. That's at -5. My variable for range is y, and my highest y value is 4. At -5, it's a closed dot, therefore the sign is going to be less than or equal to, and at y equals 4, the dot is open, therefore the sign is going to be less than. This one is going to be the exact same steps as number 1. I'm going to let you try that one on your own. Number 3 is just like number 4. Therefore, I'm going to do number 3, and that gives you an opportunity to try number 4. My domain is going to be all of my x values in this mapping, and my y values are going to be my range. How do you write the domain and range for discrete functions like this? You use the curly brackets and put the domain and range in order. -1, 0, 1, 2, and 8. My range is going to be -3, -2, 2, and 3. Number 4 is going to be the exact same steps. So I'm going to let you do number 4 on your own. Flip it over to the next section. These are exponent rules. You get these exponent rules on your reference sheets. Therefore, it's going to be very important that you use these as reference. Which expression is equivalent to this one right here? This is using quotient of powers. And it's also using negative exponents. I can see the negative exponents right here. That's going to help me reference the exponent rules that I have above. Quotient of powers means that I divide my coefficients and then I subtract my exponents with the like bases. I do not subtract this 14 minus 8. I divide here. Both 14 and 8 can be divisible by 2. 14 divided by 2 is 7. 8 divided by 2 is 4. That being said, I can eliminate g since it has 6 as the coefficient. Now I'm going to subtract my exponents with the like bases. A to the 4th power minus a -2, that's going to become keep, change to equal a to the 6th power. B to the 6th power minus 3 is going to equal b to the 3rd power. C to the -10 minus a -5 is going to equal c to the -5. Putting this all together, my 7 would be on top, as well as all of my positive exponents. A to the 6th, b to the 3rd. This c to the -5 is going to follow the negative exponent rules, which means it's going to go on the bottom now, and the exponent is going to become positive. Therefore, I'll put c to the 5th power on the bottom. That being said, my answer is H. This is going to follow the exact same rules as number 6. I'll let you do number 6 on your own. Number 7 is the opposite. I am multiplying these two expressions, therefore this is product of powers. We're going to do this in steps. 3 times 4, you multiply the coefficients rather. 3 times 4 is 12. X to the second power times x to the first power. This single x right here is x to the first power. I'm going to add these exponents. This becomes x to the 2 plus 1, which is x to the third power. That eliminates me down to c and d. And then this becomes y to the fourth power times y to the second power, which equals y to the fourth power plus 2. This is going to be y to the sixth power, which means my answer is D. Number 8 is a little bit different. This is a power to a power. This is power to a power rule. If you look at your exponent rules, power to a power means that I multiply my exponents. I'm going to distribute this 2 to each of my terms inside of my parentheses, though. So this becomes 6 squared, which equals 36, not 12. This becomes x to the third power squared, which equals x to the 3 times 2, which equals x to the sixth power, y to the sixth power squared equals y to the sixth power times 2. That is y to the 12th power. In total, it gives me 36, x to the 6th, y to the 12th, which is A. Number 9 is determining the slope from the table. This is a clip from your reference materials as well. Your slope equation is given to you. y2 minus y1 over x2 minus x1. You could pick any 2 points in this table. I'm going to pick my first 2. F of x is the same thing as y. I'm going to label my rows. This is going to be y2, which is 1, minus 0 over 2 minus 1, my x values. This becomes 1 over 1, which just equals 1. There's my slope. Number 10, you can either do rise over run whenever you're given the graph, or you can use the equation. In this case, because I did the equation right here, I'm going to do rise over run. So picking this point right here, my next point is up here. I'm going up 10, 20, 30, up 30. Be careful because these are counting by tens. And then over 1, which is 10 on the y. 30 over 10 reduces down to 3 over 1, which is just 3. Number 11 says graph the equation. In order to graph, I need to identify my m, which is my slope, and my b, which is my y-intercept. My m is the coefficient in front of the x. It's 3. My b is 4. That's where I'm going to start, is my y-intercept. I'm going to go over to 4 on the y-axis. 3 is really 3 over 1. Rise on the top, run on the bottom. This means I'm going to go up 3, 1, 2, 3, over 1. Draw my line. This equation is not in slope-intercept form. This equation is in standard form. If I look up at the top, there's my standard form. I want to convert it into slope-intercept form, which means I have the x on the left in standard form. I have the x on the right in slope-intercept form. That means I need to use inverse operations to solve for my y. This is a positive 3x right here, therefore I'm going to subtract 3x from both sides. This gives me 4y equals negative 3x plus 12. These are not like terms. I cannot combine them. To get rid of the 4 in front of the y, I'm going to divide everything by 4. And this gives me y equals -3 over 4x plus 3. Now you have your equation in slope-intercept form. I'm going to have you use the same steps that I did for number 11 to graph number 12. Number 13 is very similar. It just has an inequality rather than an equal sign. So that means I need to have 4 pieces of information. I need my slope, I need my y-intercept, I need to know if my line is broken or solid, and I need to know what my shading is. Those 4 things are needed in order to graph inequalities. My m is the coefficient in front of the x, that's 4. My b is -2. This is a less than inequality, so therefore my line is broken. And the shading, this is less than, so that means that this is below. Graphing my y-intercept at -2, my slope is really 4 over 1, which is rise over run. Up 4, 1, 2, 3, 4, over 1. My line is broken. Ooh, look at Masuko. Make my line a little bit broken like that. And then I'll put my arrows. My shading is below. That's where all of my solutions are. Number 14 is going to be the exact same setup, except you don't have a less than. This is greater than or equal to. Therefore, the line and the shading will be the exact opposite of your number 13. I'm going to let you do number 14 on your own. Number 15 says write the equation for the graph. In order to write the equation for the graph, you need slope and you need your y-intercept. However you get that. My y-intercept is the point where the line crosses the y-axis. The line crosses the y-axis in between -60 and -80, which is at -70. The slope you can do a couple of different ways. You can do it as rise over run, or you can use your equation, m equals. In this case, I'm going to do rise over run. So here's one point right here. Here's another perfect point to use rise over run. Be careful here. When I go up 1 in this case, it's really going up 10, since you can see that the scale is 10, counting by tens on the y-axis, as well as the x-axis. So I'm going over 10, 20, 30, 40, 50, 60, 70, 80. I'm going to the right. That means that the slope is positive and going up as well. 10 divided by 80 gives me 1 over 8. Here's my y-intercept. Here is my slope. Let's write our equation in y equals mx plus b form. This is on your reference materials. Y equals 1/8 x minus 70. Those same steps are going to be followed for number 16, except you know that your slope is negative. It is sloping downward, going down a roller coaster from left to right. Number 17 is just like one on your CA. You need to write the equation now from a table. There are 2 ways that you can do this. You can find slope, and then you can use point slope. That's an equation that's given to you. If I were able to look at my table and see my y-intercept, I could do that. But there is none where x is 0. Your y-intercept is when x is 0. In number 18, you have your y-intercept in your table. That's your b value. But you do not have it in this table. So your first plan of attack could be doing it by hand, finding the slope and using point slope. Or for a shortcut, you can use linear regression. By putting my values in the calculator. Let me zoom out so that you guys are able to see this really well. You'll push Stat. Edit. Your X values will go in your L1. Your Y values will go in your L2. X values -1, 2, 4, 6, and 7. Your L2 is your Y values. 4, 7, 9, 11, and 12. Now I'm going to go back up to Stat and click Calculate. I'm going to scroll down or hit number 4 for linear regression. These are linear equations, and this gives me my equation. Substituting in my values for A and for B, y equals 1x plus 5. Do I even need to write the 1? Nope. Y equals x plus 5. If I wanted to convert this into standard form, ax plus by equals c, I would need to move the x over from the right to the left. I'd subtract x on both sides, and I would get -x plus y equals 5. I told you two things that a, or the coefficient in front of the x, cannot be. It cannot be negative, nor can it be a fraction. So because this is a negative value right now, I've got to change all of my values to be the opposite. This would be x minus y equals -5 in standard form. Number 18 is just like number 17. It also gives you your b if you were looking at it in the table. Go ahead and do number 18 on your own. Number 19 is asking you to write the equation of a line with a slope of 10 and passes through this point. If I'm given slope and a point, I'm going to look back on my equations in my reference materials. I'm given a point and I'm given the slope. I'm going to use point slope form. This equation is where I'm going to solve. I'm going to set up my table, x1, y1, and m. My x1 is 4. This is my x value. This is my y value. My y1 is 8. And my m is 10. Y minus y1 equals m. Ooh, it's so dark in here. Let's see who's got to turn the light back on. Equals m times x minus x1 is my blank. My y1 is 8, my m is 10, and my x1 is 4. There's no keep change here because I don't have any double negatives, but I need to distribute this 10 in order to get my y by itself. So I have y minus 8 equals 10 times x, which is 10x. 10 times -4 is -40. In order to get my y by itself, I'm going to add 8 to both sides. This is y equals 10x minus 32. That would be my equation in slope-intercept form. In standard form, ax plus by equals c. I would subtract 10x from both sides in order to get my x on the left side. This would be -10x plus y equals -32. I told you that this number in front cannot be negative, nor can it be a fraction. So to change all of the signs would be to have it be 10x minus y equals 32. That would be it in standard form. Number 20 is a little bit different than number 19. It doesn't give you the slope and a point. It gives me 2 points. There are two ways that I could do this. I could find slope. What can you find between 2 points? You can find slope, and then you can use point slope just like you did in number 19. Or if you have more than 1 point, you can use linear regression. You just saw me do slope using the table, and you just saw me use point slope for number 19. So I'm going to do linear regression given just 2 points. I can set up a little mini table to even help me organize my values. My x is 6, and my y is 2 for my first point. My x is 9 for my second point, and my y is 3 for my second point. Now I'm going to use linear regression. Go into edit again, which is number 1. I'm going to clear out my values from L1 and clear out my values from L2. My x is 6, my other x is 9, my y is 2, my y is 3. Stat, calculate, linear regression, go. This is y equals 0.33 repeating x plus 0. That's substituting in my values. I want to convert 0.33333333 into a fraction. Math, frac is number 1. Oop. Click enter, and that gives me 0.33333333. This is probably one of those trickier ones. These repeating 3 values are a very common decimal for 1 divided by 3. 1/3 is 0.33333. That's something that you should probably know and remember. Also, you would hope that you would have multiple choice answers for this type of problem so that you could identify that the slope is really y equals 1/3 x plus 0. Do I even need to write that plus 0? Nope. If I wanted to write this equation in standard form, I would subtract 1/3 x from both sides, and I would get negative 1/3 x plus y equals 0. I have nothing left over here on this right side. I told you that my x value, the coefficient in front of my x value, cannot be negative. I'm going to go ahead and change my signs. 0 doesn't have anything change. Also, I cannot have a fraction as my coefficient. I'm going to use David's suggestion and immediately do the distribution to the negative y and the 0. I keep whatever's on top. 1x minus 3y. Now we have a negative y. 3 times 0 is just 0. Do I have to write the 1? Nope. Do I have to write the 0? Yes, in this case. X minus 3y equals 0 would be my equation in standard form. Hopefully this was helpful to all of you. Good luck on your test either tomorrow or on Wednesday.